My name is Susan Cohen. I've been teaching 8th grade science for just about 20 years now at a middle school in an urban setting. 5 years ago, I worked with the NGSS Diversity and Equity Writing Team to teach a case study about the flow of energy in an ecosystem and considered race and ethnicity with respect to the NGSS. This video series focuses on the next generation science standards in my middle school classroom.
So we've been talking the last couple of days about bats and what's happening to the bat population. When they say there is a 95 to 100% mortality rate with the white nose syndrome illness, they're saying 95 to 100% of those bats die.
We are trying out a unit written by Dr. Kevin Anderson about bats, designed to meet the NGSS.
And then they said then the second threat is white nose syndrome, which we have right there. And then
Why is white nose syndrome a threat?
because it wakes them
You've
up.
got to
and,
tell me why, right? It's okay to say it is, but then you've got to prove it, or you at least have to give me enough evidence that it's going to support your claim.
We will look at the NGSS from 4 different lenses. 1, phenomenon-based, 3-dimensional learning. 2, supporting student ideas about the phenomenon. 3, student ideas about practices. And 4, flexibility of the dimensions.
So yesterday we did the posters on the bats. I apologize, I don't have everybody's up. I have some up. If you still have your bat poster, I'll take it now. The central question for today is, what is happening to the bat? So this is a bit of data that comes to us from New Jersey. I want you to look real careful. It's the summer bat count. Every summer they go out and they count. Who did big brown bats? Yeah, who did little brown bats? Okay. Here's a baseline number when the population was stable. 2009, big brown bats, 850. 2010.
The NGSS focuses on students acquiring 3-dimensional learning. This means that students use science ideas and cross-cutting concepts as tools to collaboratively engage in practices to explain and predict phenomena. In the Midwest, where this unit was taught, there are a lot of bats. Bats live in tunnels and under eaves, in trees, and in attics. Students are fascinated by bats, the only true flying mammal. Bats are also one of the most ecologically important animals in the world. For a phenomenon-based unit, the phenomenon must have a few important features. It must be engaging, relatable, and relevant to students. The task of explaining the phenomenon must inspire different ideas from students, and it calls for a combination of disciplinary core ideas and practices and cross-cutting concepts.
3 questions. Tell me, what do you observe when you're looking at this data? 2, what questions do they make you ask? 3, if I was going to represent that data mathematically, what would be the best way to do it? Okay?
In a phenomenon-based science unit, I don't focus on students acquiring science ideas as discrete facts. I help them hone their capacity to explain new phenomenon.
This one is decreasing, and this one is increasing.
Can you please tell me how you're going to represent this mathematically?
On a line graph, because then you can have the 2 different lines, one for the big brown bats and one for the little brown bats.
Okay, and why is that good?
Then you can see both at the same time.
The driving question anchored the students in the phenomenon. The question, what is happening to the bats, is tied to the disciplinary core idea LS2.C, which is ecosystems, interactions, energy, and dynamics. The practice is analyzing and interpreting data. And the cross-cutting concept is systems and systems modeling. And we looked at things like graphs, because I really wanted students to be able to think about it more than just as a narrative type of science story. Actually think about it analytically, to think about the numbers involved and the patterns that were coming out of those numbers, and we could see all that on graphs.
I heard some really good observations, I heard some really good questions, and I heard pretty much the same ideas for how to do it mathematically. Anybody want to give me any more ideas for how we could represent this besides the line graph? Yeah?
You can see the comparison from one to the other.
How many pie graphs would you need?
A lot, a lot.
But you could do it. You would just need more than just the one graph.
6.
At least 6. I think you're right.
You could also do a bar graph of the combined totals.
What would that show me?
It would just be like filled in and you could see the decrease.
Okay, you could definitely see the change over time.
They analyzed data and used math to describe the phenomenon and ask questions about cause and effect.
It's going up by 500, right?
Yes, on the y-axis you're just going to go up by 500, so you can include all full and bats. And then for on the bottom you're going to do the year, so that's 2090 through 2013.
Next, we engaged in text and media.
And each of you read at least one website and summarized it as far as what was threatening bats. Today I'm going to give you some more information. It's going to come to you in the form of a video.
2 really big threats have come to threaten the bats even further. The biggest one of those is a disease called white nose syndrome. This disease was first discovered in 2004 in a cave in upstate New York.
We constructed the explanations that they will revise after they know more about biodiversity.
So which is the main one?
I think humans and so like deforestation and white nose syndrome.
You guys agree?
I think that one's probably pretty big, and also the pesticides are probably really big too.
And what was the other
The
one?
pesticides.
You can write this any way you want. I'd like you to tell me what your main claims are.
So the claims, evidence, reasoning piece was a way for them to sort of get their mind around what was happening to the little brown bat, why it was happening, and that this evidence was really worthy of investigating further. To figure out how biodiversity works, we went outside to carry out an investigation about biodiversity and began to think about a species as part of a whole ecosystem.
You can either write the word dandelion, leaf, or you can draw a picture that looks like that.
And from that, we tried to connect that to how the little brown bat was just one thing in its environment. The unit equips students with the tools to explain the phenomenon in increasingly sophisticated ways. As their ideas and use of cross-cutting concepts became more refined, their practices became more persuasive.
So you've got your claim, that's fine. Now you have to give me some evidence to support that claim.
There's a 95 to 100% mortality rate
Okay, so why didn't it kill them all off before?
because it was recently discovered. Like, before that, nothing was going to happen with it, but then people brought it to other caves.
So it wasn't here before. So we want to say that. We want to say this sudden decline is the result of what?
We will see in this video series how the phenomenon of disappearing bat species offers leverage for engagement and a variety of disciplinary core ideas, practices, and cross-cutting concepts, giving rise to rich sense-making with lots of different students' ideas.